All right, then what about geometric sequence? This is what we used yesterday in class, but just like the arithmetic sequence, instead of k, I'm going to use 1. So g sub n is equal to g sub 1 times r n minus 1, and let's just stick with that. Okay? All right, I'm going to do example 7 on your notes. Okay, g sub 1 is 12, r is 2, find g sub n and g sub 4. So let me write it down here. So g sub 1 is 12, r is 2. All right, so let's plug it into the formula. G sub n is equal to g sub 1. Ooh, we already have that. 12 times r, 2. Ooh, raised to the n minus first power. All right, so here's the thing. Yes, that's the equation of this geometric sequence. However, the key here is that you should be able to change this so that you can only have 2 to the n power by itself. Why? Because sometimes this might be in the multiple choice, and I can probably guarantee you that you're not going to see this a lot. Okay? So how am I going to do it? Folks, do you remember this? Like if you have x squared times x to the 5th power, it's going to be x to the 7th power. Like when you have a multiplication with the same bases, you just add your exponents like that. Yeah, so we're going to work backward. So right now my exponents are, I know it's a subtraction, but like it's n plus negative 1. So since they are added, I'm going to split this up like this. 12 times 2 to the n power, 2 to the negative first power, like that. Right? Because your exponents are added. So I just split into 2 separate ones with the same base 2. Now then, this becomes 12 times 2 to the n power times. Do you remember what to do with the negative exponent? Yeah, you flip it, you reciprocalize it. That's like a word I use. So half to the first power. And now everything is being multiplied. So I'm just going to multiply 12 and 1/2, which is going to be 6 times 2 to the n power. So that and that, well, all of them are the same expression, but you should also notice that that's like these two are the same thing. Yay! So you can probably see that on multiple choice as opposed to this one. All right, now then we are supposed to find g sub 4. Just take that 4, plug it in. And then always follow the PEMDAS, okay? 2 to the 4th power is 16. 6 times 16 is 96, I think. There you go. That was pretty good, wasn't it? All right, now then, I'm going to do the whiteboard problem that we did, and it was this problem. G sub 2 was 1, and G sub 5 was 27. Let's find the formula for this geometric sequence. All right, so just like the arithmetic sequence where I come up with a 2 equation and then solve by systems of equation, that's what I'm going to do. So let's first plug this into over here. So n is 2. So g sub 2 is equal to g sub 1 times r. I don't know what that is. And n is 2. 2 minus 1. I got g sub 2 is g sub 1 times r to the first power. All right, now let's use this one. N is 5, plug it in 5 and 5. Then I got g sub 5 is equal to g sub 1 times r, 5 minus 1. G sub 5 equal to g sub 1 times r to the 4th power. All right, I forgot something over here. G sub 2 is 1, so I can actually put 1 in. G sub 1 times r. G sub 5 was 27, so I can say 27 is equal to g sub 1 times r to the 4th power. Okay? All right. Last time we like put them up and down and then like subtracted to the elimination. So I don't know what I got. So I'm just going to put the second equation under the first equation. Then I got 27 is equal to g sub 1 times r to the 4th power. Unfortunately, I can't really like substitute. I can't just subtract like elimination. It's too much. So here's a little hint. I'm going to divide the first equation by the second equation. Wait, can you do that? Yes, you can. Why? Because they're the same thing. When everything's the same thing, you can divide by the same thing over same thing. Right? Then see what happened. 1 over 27 is equal to, I cancel this g sub 1 out, and I cancel that r out, that I'm left with 1 over r cubed. Look at that. Okay, so 27 is r cubed. Then what's r? What cube gives you 27? 3. Okay? Alright, once I got that 3 in, so r is equal to 3. What else do I need to find out? I need to find out what that g sub 1 is. So I'm going to take this, sorry, it's a little messy. I'm going to take this equation out. 1 is equal to g sub 1 times r. Well, r is 3, so I put that 3 there. Divide both sides by 3, so g sub 1 is 1/3. G sub 1 is 1/3. Dang, we can come up with the equation. Remember this? Oh, remember, where am I? Remember this? So g sub n is equal to g sub 1, 1/3, times r, 3 to the n minus first power, like that. Just like arithmetic, where we have to clean it up. Well, just like this one. You know how we have to clean up your exponent a little bit? So we have to clean this up as well. 1/3 times 3 to the n power times 3 to the negative first power. I just split that n minus 1 exponent as like this. Okay? And then 3 to the negative first power is 1/3. Do you know, you can just multiply now. 1/3 times 1/3 is 1/9. 3 to the n power. So g sub n is 1/9 times 3 to the n power. Okay? And I think the whiteboard also asks you to find g sub, I don't even remember, 6 or something. You just have to plug it in and find out what that is. Okay? Alright, thank you so much, and I hope this video was helpful. Bye-bye.